Hello friends, in the previous video we talked about creating an SSL socket and a key store for the client side, which is this part, and we implemented on a real application. In this video, on the next one, we will talk about the server side. We will create an SSL socket for the server side with multi-threaded, and we will create a key store for the server side. Now the objective of this video is that we need to create a key store for the server side on the server machine, and then we save all the encryption keys and certificates that we have created in this key store. And the second objective is that we need to create a multi-threaded sockets on the server side so we can accept the connections from the clients. Now the making of the certificates and the bidirectional client-server authentication process, I already covered it in my previous course, the PostgreSQL database and SSL certificate, so I won't go through them again in here. But in that, for those of you who wish to know how we can do these certificates, they may go and check it in my previous course. But in that course we have created the root certificate and root key, intermediate certificate and key, trust chain certificate, server and client certificates and keys. Now when we do the authentication on the application side, in the key store of the application side, we need three important things among other things, but these are the three important things that should be existing on the key store of the application side, of the client side. That they are client key, client certificate and intermediate certificate. The intermediate certificate, we will use it to authenticate the server. Now on the server side, on the key store of the server side, we need, among other things, we can place all these things in, but we need most importantly the server certificate and the trust chain certificate that we will use to authenticate the client when they need to connect to the server. Now as I used to, we will do these steps in here, and I will go through them step by step to explain them, and then we will start, after explaining all these steps, we will start implementing them so we can create the key stores on the server machine. Now remember, I'm working at this stage at the server machine. Now as I have said, the objective of this video, that we need first of all to create the key store, and then we create the multi-threaded sockets. So these steps in here, we will talk about the creating of the key store, which have two options: either we use the Java security or we use the custom provider. And once we have done creating the key store, then we will go through the steps that we have made in the client side to create the SSL socket, because the steps are almost identical except for few things that we need that concern creating a multi-threaded sockets, because on the client side we just need one socket to connect to the server, but on the server side we need a multi-threaded sockets, because there are a lot of clients which want to connect to the server. So this is the extra thing when we do with the server side. So again, we create the key store and then we create a multi-threaded socket. In here we have two ways to create the key store, either using the Java security providers or we use the Bouncy Castle, the custom provider. And after we do that, then we start creating the multi-threaded socket, which is almost identical like what we did in the previous video when we created the SSL socket for the client side, except that we will add few more steps that related to creating a multi-threaded socket. So having said that, let's start the steps, and the first option is that we will use the regular Java providers to create the key store, and we can do that on a regular terminal in our server machine. Okay, so the first thing is that we need to install the JDK in our server. This is the first thing, whether JDK 8, 9 or 10 or 11. Now remember what we have said in the previous video, that Bouncy Castle is tested with JDK up till now. February 2019 is this Bouncy Castle FIPS mode tested with JDK up to 1.8. So if you wish to go here with creating the SSL socket with the Bouncy Castle, then this JDK, which should be installed on the server, should be no more than JDK 8, so that the Bouncy Castle can work with. Now if you choose here, when you create the SSL socket, not to use the Bouncy Castle and use the ordinary regular Java provider, then yes, you can use JDK 9, 10 or 11, whichever you want. So this is a very important point to notice. Now supposing that we will go with the JDK 8, so we can fit for both of them, so we can use also the Bouncy Castle FIPS mode provider. The first thing is that after installing the JDK is that we create the key store. This is the first thing. And to create the key store, we open a terminal, and on this terminal we start with this line of command line. And the command line concerned this key tool, then gen key, which will generate a key for us. We will give a name for this key or for this key. This name will be like any name you wish to choose. It will be like a reference, like a label for this key, so you can refer to it later on when you want to use the key. And then we give the algorithm that we wish to use. In my case, I'm using RSA. In your case, you could use whichever algorithm suitable for you. And then we use the flag key store flag. This will create for us the key store. Now here you need to notice that where you wish to put and save this key store. So this is a directory where you wish to place the key store. In my case, I'm using the root, but in your case it's up to you to select where you wish to save the key store. And then you give the key store a name, whichever name suitable for you, and then .jks, which is Java key store. And then you use the key size flag, which will give you the encryption strength. Here I'm using 2048. Now remember, you can use the 4096 bit for encryption for the key size, but that will push, or that will put an extra load on the server when it will work, because when you encrypt and decrypt, when you get out the data from the key store, this encryption decryption process, if you use the 4096, will affect the efficiency of the process and of the server, and it might reduce the performance. So I think 2048 is a good choice between the security and the performance of the server. Now once you have done this, you enter. It will request from you a password for this key store. You choose your password, and that's it. Your key store have been created. Now once you have done this, you will get a warning, or actually it's almost like an error, telling you that the JKS, this is the error that you will get. The JKS key store uses a proprietary format. It is recommended to migrate to PKCS12. Now PKCS12 is another type of the key store, and it's one of the most recent and also is a robust type of key stores. So once you have got this warning, then you need to change the type of the key store to PKCS12, and you can do that with this line of code, exactly as it is. You need to place the location of your key store and the name of it, of course, and keep the same thing, except that at the end of it you will select the PKCS12 as the new type of your key store. Once you have done this, another warning will come up to you that prompt you to delete the old key store, because now you have a new key store with PKCS12. So you can also remove it from your server machine, and that's it. Up till here, this is the creation of the key store have been completed successfully. Now what you need to do is that the certificate that you have created before, the server, the client, the chain trust certificate, all these certificates that you have been created, you can import them on this from the server and place them in this key store of the server. And the way to do that is by implementing this line of code. Now you can do this one step at a time, means each certificate or key you need to import it once at a time, and for each one of them you need to give an alias, like a label, a reference name for that key or certificate, and also you need to mention where is the directory of that key or certificate, and finally the name of your key store. Remember, you need to do this step for each and every security material that you have, whether it's an encryption key or it is an certificate material. Once you have done this, there is another way also to do this same thing, is if it's the trust cert, if you add this flag, and you can Google it and you see what is the difference between this without this or the. I'm going with this type, it's more easier. Now once you have imported all your security materials, that is the key material and the certificate material, into your key store, you are good to go and you are done. You created your key store using the Java security, and you have imported all the certificate to it. Now there are other commands which you can use them. They are not related to the creation of the key store and importing the certificate. No, they are just you may want to use them if there is any need for them. These are some of them. If you Google it, you can find a lot of them. You can use them with your key store. For instance, if you want to check a specific certificate, you can call it by this code. And now if you want to know what are the contents of your key store, what certificates and keys there are saved in the key store, so you can go with this line of code. If you want to call a specific certificate by the alias name, you remember we gave one certificate an alias name, each certificate. So if you want to call this certificate by the alias name, you can do with this code, and so on and so on. There are many ways you can use these options to control your key store, but they are not related, as I said, they are not related to the creation of your key store or to the import of the security material into your key store. Now there is one last very important point when you use the Java security. When you migrate to use the PKCS12 type, remember that PKCS12 only want a key store password. If you put passphrases on your keys or on your certificate, the PKCS12 will not accept these certificates and the keys. This is a very important point you need to put in your mind when you use the PKCS12, and it is also same in here when you use the Bouncy Castle. Bouncy Castle have two types, BCFKS and PKCS12. The BCFKS accept both the password for the key store and password for the keys and certificate, but the PKCS12 doesn't accept any passphrases on the keys and the certificates. So you need to be careful when you use the PKCS12. This is all about the first option when you want to create the key store using the terminal on your server machine. Now about the second option is that when you use the customized provider such as the Bouncy Castle, as I said, it's almost the same as what we have done with the client side, except that we will add few more options when we create the SSL sockets regard the multi-threading. But there is one also important point, is that you need to put the jars of the Bouncy Castle in your server. Otherwise, you won't be able to use the Bouncy Castle implementations on the key store and on the SSL sockets, and you will default to use the, as we have said before, and you will default to use the Java security default providers, that is the Sun provider. So you need, if you choose to go with the second option, you need to remember that you need to add these jars and compile them with your program inside the server machine. Now this is all about the explanation, and in the next video we will start showing you how we will do the SSL socket for the server side, and how we will do for the key stores as well as, and I will start first by creating a key store using the Java, which is pretty straightforward things, and then we will start to do the key store using the Bouncy Castle, and then creating the SSL socket. Creating the SSL socket, as you see here, it's almost identical, the steps, except for in here we will start we use a thread factory, so we can create a multi-threaded sockets. That's it. That's the only difference for the server SSL sockets. Other than that, the remaining steps are almost identical. Okay, thank you very much.